Welcome to the Mahatma Gandhi Institute of Technical Education and Research Center. In 2004, a national level institute MGITER has been started in the field of engineering and technology as per guidelines of All India Council for Technical Education AICTE New Delhi. MGITER is approved by AICTE New Delhi, Gujarat State and affiliated to Gujarat Technological University Ahmedabad, which is also known as GTU. Our goal is to be an institute of generative ideas so that we remain relevant to our society. The MGITER has always been an organization on move with continuous effort on improving its processes and to maintain its relevance to the Indian science scenario, with adding new programs in its programmatic portfolio. We strongly believe in overall development of students, so for that we provide them a different platform like state level tech fest, project fair, different sports activity, which helps students to teach teamwork and problem solving skills to get physical health benefits, boost self esteem, and reduce pressure and stress for prove their skills in distinct area. Hi, this is Professor Gaurang Patel. Welcome to the virtual class of Power System Transients. Okay, today what we are going to learn, or our main focus of this video lecture, is to study the main sources of transients and what are the effect of transient on the power system. Okay, so let's begin with the introduction of power system transients. You can see over here, just a moment. Okay, so let's begin with the introduction of power system transients. Okay, so what exactly it's want to see that when you are talking about the transient, first of all, the picture that come into your mind, that is the over voltages. Okay, so what exactly are transients? Let's get into that. Okay, well, if we want to define that, the transients are short surge or quick bursts. Okay, and another thing, if I want to say you that transients are unavoidable and most of them are not severely damaged to the power system, but however, if the combining high voltage spikes and high current, that will be the extremely dangerous. Okay, so some of the transients, as I said, that it is not that dangerous, or it is not that harmful, but if the high voltage or high spike will introduce to the power system, that it might be effect to your power system. So how it will be affected, we can see that. Okay, so whenever you think about the transients, the lightning, that always comes to mind as the main transient cause. Okay, however, there are a lot of other devices as well, okay, that can induce transients into a circuit, many of which are internal to the facility. From those devices, many of them are the from the internal facilities that you can consider as a source of transients over here. Okay, so if I told you like that, which devices you can consider, that if first I told you that there is the lightning is occur, that is the main source, and internal devices or internal causes and internal reasons, if we are talking about that, that is the power electronic components. These are almost the major cause for the transient, that is power electronic components. Then electrostatic discharge, we are also known as, those are the ESD, that is the electrostatic discharge. Another source is, if we are talking, that it copier and printer machines, welding loads, even that furnace ovens, inductance, heaters, etc. Okay. Also, you can consider that the motor load startup and turn off, faulty grounding connections, etc. Okay, and it is estimated that 80% of transient activity at a given facility is internally generated. So 80% causes are the causes of transients, that is that was internally generated. Okay. If here we consider, that is mainly two types of transients, that is oscillatory and impulse transient. Okay, the most common transient is that oscillatory transient. This type of transients likes to swing above and below the normal line voltage. Okay, so if you consider over here, okay, so what I told you, that if you consider now an impulse, however, is more like a one shot type of event. It is a just kind of one shot type of event. What happens when a transients get into a power system, or you can say what will be the effect or severe effect will be there when transient happens to the power system. Okay, so from among of those, we can consider one of the most common indicators of the transient activity is the premature appearance of black rings at the end of fluorescent tubes. If you observed in old days, there was a fluorescent tubes we were going to use at that time, and at end of that fluorescent tube there is a black rings over there. So it is one of the reason why it is happen, that is the transients in your system. Okay, and another thing is, if we are talking that if now transients also affect the contacting surfaces of switches. Okay, when you disconnect a switch or some of the load, if you consider when you disconnect the load from that source, or you can say when you open the circuit breakers, that is also causes that is also the reason, one of the reason of causing the transistors. Okay, another cause, that is if the transformer are forced to operate inefficiently, that will be that will the windings will become hotter, and that could be going into the saturation point. Okay, so those are some of the glimpse of the effects when transients occurs in the power system. We will see in the detail one by one what are the causes and which causes, due to which cause it affects where in the power system. Okay, so let's move further. So these are the sources you can see which we discussed, that is capacitor switching, current interruption, power electronics operations, electrostatic discharge, arc welding, copy machines, faulty wiring or circuit breaker operations, contact and relay closure, load startup or disconnect. So those sources of transients are we consider as a internal as a internal sources. Okay, we will we what we should do, we will see it in detail in this video lecture. So those are the internal causes you can consider when we are talking about the transients. Okay, so now when we consider the sources of transient in internal sources, you can see there is a first point, that is switching surges due to the opening and closing of a switch in power system. How it will be affected, that is switching surges due to the opening and closing of a switch in a power system. Okay, so I will show you one very interesting video regarding that when in switch yard when the switches are opening and closing, how much arc is going to be produced and how it will be affect to your power system. You can easily understand by showing this video. I will play this video for you over here. Just a moment. So now I will show you some of the events when switches are open in switchyard for our power system when we talking about the higher high voltages system. Okay, so let's begin with that. Just a moment. One more over here, you can see. Opening
that was cool.
Of the line. Separate it out.
You ready, Ray? Yeah. You doing it?
Things what you have seen in this video.
Are you okay?
I'm okay.
So when we are talking about the switching surges due to the opening and closing of switch in power system, and that we must be consider in keeping our mind about the extra high voltage lines, or sometimes we have to making or breaking the switch for the maintenance purposes. So that kind of transient will occur, that what we seen in that video. Okay, so the first point if we discussed regarding for the internal source of that switching surges due to the opening and closing of a switch in power system, if we talk into the detail, what we have to consider first, that is you can see that is the circuit diagram. Okay, so it is having one source, inductance and capacitance over there, that is the circuit breaker that is shown over here, and that is the internal resistance in between that line, that is the shown in second graph. You can see some of the oscillatory restriking voltage and recovery voltage in the diagram. Okay, so whenever that is switching surges due to the opening and closing of switch, when we consider there is a one thing that is come into our mind, that is the extra high voltage transmission lines and power system. Okay, that is switching surges, that is very important factor, and that also affect the design of insulation as well. Okay, all transmission line rated for 220 kV and above incorporate switching surge spark over voltages. for their insulation levels. Okay, so a switching surge is a short duration, as we discussed, or it is a short duration transient voltage produced in the system due to a sudden opening or closing of a switch or circuit breaker, or due to an arcing at a fault in the system. If the you can see the waveform is not unique, the transient voltage may be an oscillatory wave. You can see that is the transient voltage, that may be the oscillatory wave. It is having some oscillations. Okay, and if the damped oscillatory wave or frequency ranging from few hundred hertz to few kilohertz, that damped restriking voltage, it is having the few hundred kilohertz wave. It depends on the severity of occurring that voltages. Okay, it may also be considered as a slow rising impulse. Okay, it is also may be considered as a slow rising impulse having a wave front time of zero point 0.1 to 10 millisecond. That is a wave front time, tail time. I was already discussed in the previous lecture. Okay, so the switching surges contain larger energy than the lightning impulse voltages. Sometime that you might have be understand how much large voltages were produced. You can observe in that video that what we just I saw you over here, how much big arc was there due to the making or breaking the context when the transmission line is in comments to the another transmission line. Okay, so when you consider this point, that is switching surges due to the opening and closing a switch in power system, those things you have to keep in mind very carefully. Okay, so after that we have to move one another important point, that is the insulation failures due to the transients. Okay, so you can see in that picture over here, you can easily understood that when that insulation failure was there, you can see over here this part. Okay, insulation, you can see that is completely damaged. You can see the eruption of that particular insulator. You can see over here that is the puncture on the disc insulator. That is also these all are the things it happens when the severe transients are occurred into the power system. And how this damage will occur, it is mainly due to these damages occur mainly due to the dv by dt stresses. You can imagine this. Okay, so when you can consider those are the failure of insulations, you can see over here like that, if the premature insulation failure due to partial discharge as a result of peak voltage, that what I discussed, that is a dv by dt and high frequency. Okay, and if the high dv by dt creates non-uniform distribution of voltage across the winding, then such kind of failure will be there. If it is a non-uniform distribution of voltage trace, so particular part of that winding will going to be damaged. Okay, so when you are talking about the electrical equipment, that is always subjected to internally generated or external voltage and current surges, because whenever you're using the electrical component, the main reason of their failure, that is the internally generated voltage or internally generated higher current or surge due to the surges. Okay, a physical rupture of insulation with the destruction of molecular bonds might occur during a voltage surge. You can see that physical damage is happen over here, that is the complete damage, or you can see complete puncture of disc insulator over here. Okay, so and when this puncture or these things are happen, that what it causes, this transitory over potential stresses the molecular structure of the insulating material. It will give you a burden of stress into the structure, molecular structure of that insulating material. That's why it is going to be damaged. You can easily see into that picture. Okay, and causing ion, and it will also the causing of ionization and failure of the insulating material itself. Okay, so the electrical stresses will be more significant with high voltage apparatus or with equipment exposed to the voltage transients. Okay, you can easily see the effects when high voltage transient will attack those electrical equipments. Okay, so next we will see the phenomenon of arcing ground. What is the phenomenon of arcing ground? Over here you can see that is, I just mentioned this three-phase line having the shunt capacitance, and it is also grounded over here. Okay, and those are the things that you can be easily see over here. This part, that is the arcing ground. This part, if the voltages are very higher, then such kind of events can be take place as well. Okay, due to the arcing ground, arcing ground phenomenon. Okay, so in this picture you can see that. Now if you want to consider the first of all definition of arcing ground, if you define the arcing ground, that is, the arcing ground is the surge which is produced if the neutral is not connected to the earth. How we can define the arcing ground? We can define the arcing ground, it will produce the surge. Okay, it will produce the surge. This kind of, you can see, this kind of surge will be there if the neutral point, this is the main reason, if the neutral point, you can see, if the neutral point is not properly grounded or it's not properly connected with the earth, then the arcing ground will be happen. Okay, so the phenomenon of arcing ground occurs in three-phase system because of the flow of the capacitance current. You can see why this arcing ground is happen in three-phase system, because in each and every where, just a moment, if you consider this is a three-phase system, every three-phase system having the capacitive current itself flowing with that. Okay, so this is the capacitive current, you can see, or okay, I will show you. ICR, the capacitive current is flowing from this line. Okay, so these are the main reasons for this phenomena occurring in the three-phase line, because each and every three-phase line having the capacitive current flowing from that. Okay, and if we see from another way, or if we discussed it in detail, if you want to discuss in detail, that is, arcing ground is an electrical phenomenon in which the voltage of faulty phase fluctuates due to capacitive charging current. Okay, what I want to make you understand, that is, if you related this arcing ground with particular this three-phase system, that you can consider that capacitive current. Okay, so in that they will says one of the phase will going to be fluctuated. You can consider any phase from this. If this phase 1, phase 2 and phase 3 over there, if we consider fault is happen that particular phase, okay, and this fault, due to that fault there is a current, external current, short circuited current will going to be flow. Okay, so if there is a faulty phase fluctuates due to the capacitive charging current, this faulty phase will be fluctuating because of the capacitive charging current. Okay, so arcing ground, you can also say that arcing ground is a surge which is produced if the neutral is not connected to the earth. Okay, then arcing ground which is produced when, I also told you, that is if your system neutral is not connected to the earth, then arcing ground will be happen. Okay, when an earth fault occur on any phasor, a capacitive fault current flow into the earth. You can easily see that capacitive current, if fault is occur in that phase, that capacitive current flowing into the earth and one arc is going to be produced. Such a current, if exceeds 4 to 5 ampere, that is sufficient to maintain an arc in the ionized path of the fault. Okay, so even though it can be a severe, if some of them is passing through that under this line and exactly at same time this will be occurred, it will be definitely going to be a major accident. Okay, so the presidency of the earth due to the flow of capacitance current gives rise to a condition known as arcing ground, in which cycling charging and discharging of system capacity through the fault. Okay, so those things results in high frequency, those things mean arcing ground results in high frequency oscillations being superimposed on the whole system, and a buildup of very high voltage and current on that particular system. So mainly you can see that the arcing ground is happen due to if one of the phase having the fault and those lines, if it is not properly earth or not properly grounded, that arcing ground phenomenon can be happen, and it can be damage the power system in several ways that what we discussed over here. Okay, so the another cause of the transient, that is the ferro resonance. Okay, so we will understood that reason of ferro resonance, how it will be occurred, with beginning with its definition. Okay, so if we consider that is ferro resonance, or if we want to define that what is ferro resonance, is that ferro resonance or non-linear resonance is a type of resonance in electric circuits which occurs when a circuit containing a non-linear inductance. Okay, whenever circuit contains a non-linear inductance, the ferro resonance will comes into the picture. Okay, whenever this circuit, if we consider this circuit and if it contains the non-linear inductance, okay, if it contains the, I will just write it down for you, if it contains the non-linear just a moment. Okay, it non-linear inductance then the ferroresonance phenomenon will be happen. Okay, so and another thing, that is when if you show that in the circuit diagram, there is one transformer, is you can see the transformer, the voltage source is there. Okay, you can see over here there is one transformer, you can consider over here. You can see there is a voltage source which is connected with the transformer. There is a shunt capacitance over there. Two switches are given in the system. How it will be going to be work, I will explain you one by one how this ferroresonance is going to be occurred. Okay, so whenever the circuit is subjected to a disturbance such as opening of a switch to exactly focus ferroresonance in specific situation is very intricate, because the phenomenon shows a chaotic behavior. Whenever it is happen that it shows a very chaotic behavior. Okay, the magnetic coupling between the phases in the transformer is one of the key factor regarding occurring ferro resonance. Okay, the magnetic coupling, you can see these are the two windings over here. The winding one, if we consider primary winding, and this is the secondary winding. If there are two winding and the magnetic coupling between there, so that is one of the reason why the ferro resonance will be occur during the magnetic coupling of that two windings. How it will be related, I will show you. Okay, now let us consider a power system. Okay, let us consider a power system consisting of a source and a transformer. Over here, if we consider, that is a power system that is consisting of source and that transformer. Okay, the transformer is connected to the source by mean of high capacitance cable over here. Okay, you can consider over this is the high capacitance cable. Okay, this is the high capacitance cable, what I already put it for you. That is the high capacitance cable is connected. Okay, you can easily see in the figure. It is obvious from the figure that even in case of switch S2 is open, magnetizing current I is flowing through the transformer through shunt capacitance of cable. If you opening of this switch, the magnetizing current still it can be magnetizing current I still it can be flow from this way. I just make it clear so you can easily see that it, if this switch S2 is open till the magnetizing current flowing in this magnetizing current flowing in this direction, you can easily see the path. Okay, so thus it makes a series circuit of cable. It is make the series circuit of cable capacitance and transformer reactance. In fact, transformer reactance does not only depends upon the frequency, but it also depends on the magnetic flux in the transformer core. Therefore, the reactance will flow the saturation of magnetizing curve of the core. Okay, so thus for that condition, you maybe consider that particular value of flux in the core, it may happen so that inductive reactance becomes equal to capacitive reactance. Okay, some of the things it may happen, and that's why the inductive reactance is equal to the capacitive reactance. Okay, I will show you how it will flow that curve. Okay, which is unknown, that is the particular curve for that ferroresonance occur and how uh, how it is flow. Okay, so if we consider it mathematically, you can see over here omega L is equal to omega L is equal to 1 upon omega C, and over here that is L is equal to 1 upon omega square C, as L is a variable here. So that's how it happens. That is, and also you can consider for the transformer inductance L, resonance will take place. The resonance is called ferroresonance because it is happens due to the variable L or variable inductance. Okay, and due to that ferroresonance, the current through the circuit will be very high. The current flow from the circuit is very high. The high current will, and this high current will cause the higher voltages. Okay, now if you consider this particular phenomenon, that is called ferroresonance, that can be explained by using graphical approach as well. Now consider this vi characteristic of inductance and capacitance, which is shown over here in figure. Excuse me. So when the inductive reactance of the transformer core consists of two regions, linear and non-linear characteristics. Okay, the positive operation points are obtained as the intersection of VL, that is, you can consider over here, that is the red line, that is VL, that is inductive voltage, and VC, that is the capacitive voltage. Okay, so what I want to make you understand, that if the inductive reactance, okay, inductive reactance of the transformer core consists of two regions, linear and non-linear characteristic. Okay, so that is when it was possible, when it will be the intersected with, it would be intersected with Vs plus Vc. Okay, yeah, and those are the points it will be considered when it is going to be intersected with this line. Okay, so just a moment. Okay, okay, yes. So now you can clearly see this line, that is inductive voltage and inductive capacitance, which intersected with the Vs plus Vc, and 3 points are to be considered when it was going to be intersected. And these 3 points, that is point number 1, if you can see over here, that is the point number 1. What point number 1 is suggested, that it is a stable non-ferroresonance mode, or it is considered as a stable non-ferroresonance mode. At this point, the circuit is working with the inductive mode and remains there in the steady state conditions. Okay, when you consider this point 2, that is point 2 is stable it is known as a stable ferroresonance mode. At this point, the circuit is working with the inductive mode with both high voltage and current. Okay, this solution also remains there in that steady state condition. And this point 3 is an unstable mode. Point 3 is considered as an unstable mode, and the solution will not remain there in the steady state condition. Okay, so those are the 4 things that is considered in his, I will show you. Okay, So those are the four things are the internal sources you can consider over here. First, we discuss switching surges due to the opening and closing of switch in power system. Second one, that is the insulation failures. Third one, that is the arcing ground. And fourth one, that is the ferro resonance. Okay, so four those four are the major reasons for the considering or occurring the transients in the power system. And what are the effects? I already discussed those effects with that occurrence of that reasons as well. Okay, so now further we consider the external sources, that is lightning and the traveling wave. I already discussed both of the term in previous video as well, that is the what are the causes of lightning and what are the effects when lightning will be there on the power system, and what are the traveling waves and what will be the effects. But I will discuss with you in this video as well, so you can understand it better. So first of all, I'm going with the traveling wave over here. Okay, so you can see that the traveling wave, if you can say what is a traveling wave, or if you consider that is a definition of traveling wave, that you can consider that is traveling wave is a tem- temporary wave that creates a disturbance and moves along the transmission line at a constant speed. Okay, such type of wave occurs for a very short duration, but it cause a much disturbance in the line. It is having the short duration, but it can be cause a much disturbance in the line. And this traveling wave is set up in the transmission line mainly due to the switching, faults and lighting. Those three are the major reasons. That is, uh, one of them is switching, another one is lighting, and third one, that is the fault. Okay, those three are the main reasons for occurring the traveling wave. Okay, the traveling wave can be represented mathematically in a number of ways. Okay, and we can consider over here. Okay, so it is mainly most commonly represented in the form of infinite rectangular or step wave. A traveling wave is characterized by its first specification as illustrated from this figure as well. Okay, so it is having the different section of that traveling wave, and it is known as a specification of traveling wave. Okay, so it is having the parts, that is crest, front and tail, and each one having their own definitions. If you have a discussing with that considering that traveling wave, so what is, first of all, we'll start with the crest. What is crest? If you would like to define the crest, so it is the maximum amplitude of the wave, or you can say crest, that is it is having the maximum amplitude of the wave. This portion is known as the crest, which is having the maximum amplitude, and it is expressed in kV or kilo, it is in kilowatt or in kilo ampere. Okay, the next one, that is the front. Okay, next one, that is the front, and it is defined, that is the portion of the wave before the crest. It is the portion of the wave before the crest, and is expressed in time from the beginning of the wave to the crest value in milliseconds or or microseconds. It can be considered from the beginning of the wave, and further part, that is the tail. Okay, and the tail of the wave is the portion beyond the crest. Of course, you can see over here, that is the portion beyond the crest. It is expressed in time from the beginning of the wave to the point where the wave has reduced to 50% of its value at its crest. That is you consider as the tail. Okay. So I hope you understand that is what is the traveling wave over here. Okay. And if you want to discuss in the detail what is traveling is, so you can be easily understand about the traveling wave from this diagram and the specification of that factors. Okay, now further we will talking about the lightning transients. Okay, and it is also this lightning transient is the major reasons to produce the transients in the power system, and it affects the power system. It affects the power system in many several ways. So those transients can be affects your power system in many ways, like that it is having a small duration, but it is having a severe effects on the power system. Okay, so if you observe, typically when the transients are impacting the electronic controls and data transfer or storage capacity. Okay, that typical symptoms include frequent shutdowns, tripping operations, and the impact it may vary depending on the ability of various devices and connecting mediums such as cables, EMI, grounding, and earthing configuration, etc., to withstand such transients. One another thing, that is the exposure to repeated transients, can also lead to slow damage of components, eventually leading to failure as well. Okay, however, given their nature, such repeated transients are relatively easier to trace and arrest because of that. Typical symptoms include failure PLCs, control units, screens of HMI, dashboards, devices, etc. Okay, and uh, if the severe conditions will be there, that it will be failures from extreme transient events, and it is clearly evident from its impact. The lightning with a direct strike to a phase conductor generally causes the line flash over near the strike point. If the lightning will be occur at that particular phase point, that it is will be the definitely damaging your equipment, and probably it will be going to be damaged. Okay, it also causes a fault due to the voltage sags and interruptions that result from the lightning event. Okay, a strong foundation in terms of proper grounding along with an appropriate electrical network wide surge protect it maybe protects your system, or to help to minimize or prevent the impact of these transient events. Okay, so you can be minimize those impacts with the proper grounding of your systems from that transients. Okay, so now we will see finally those things are very important to understand, because it is a really a very serious issue if you neglect those things, and if you not provide any remedies to eliminate those transients from your power system. So I hope you can understood what are the sources of transient from this explanation, and what will be the effects of the transient in our power system. Okay, so finally we will see how the question was asked in examination, so you can make your preparation regarding the examination as well. Okay, So you can see that is the question asked in JTU so many times. So this is the very important discussion that that comes to know. Okay, the list out the sources of transients and explain how transients affect the power system. This question was asked in winter 2019, also in 2018, and also in 2017. Okay, so that was the question, repeatedly asked question. So I hope you will be prepared it very carefully for your examination, and you can easily able to make the answers from the explanation of this video lectures. Okay, so I hope now you able to give the answer of that. That is the what are the sources of what are the sources, main sources of transients, and how it will be affected to our power system. So once again I would like to say that prepare it carefully, because it is asked so many times in the examination. Okay, I hope you make yourself understand with this video. Thank you very much.